Hi, I'm Charlie with Precision Matthews, and today we're going to discuss an important concept when it comes to measuring parts accurately in the machine shop. That is cosine error. Now that name may seem intimidating at first. Cosine? Am I expected to remember all the way back to first period trig class in high school? Don't worry, you can continue your decades-long unbroken streak of never having to use so, ka, toa in real life. Cosine error really just means you didn't measure right. So we're going to show you how to measure right. Let's get started. Now I was going down my quality control checklist, making sure that we didn't get cheated on length when we ordered this 6-foot work table. But I think we made out on this deal, and they accidentally gave us extra table. It's almost 6.5 feet. I also found some odd measurements when I was charting the growth of my large son, Gabriel. I got my combination square and scribe and marked where his head came to, like I do on every one of his birthdays. Then I got out my tape measure so I could send his new measurements to all his aunts. What I found was kind of strange. It said he was almost 7 feet tall. Now, of course, the problem is obvious at human scale. If you've got cosine error, instead of measuring this dimension, you're measuring the hypotenuse of a right triangle. The more obtuse this angle is, the more the hypotenuse differs in length from the leg of the triangle that you're trying to measure. Being a little bit off only affects the measurements a little, because this hypotenuse is not that much longer than this leg. But the more you're off on this angle, the larger the hypotenuse, and the more your measurement is off. And now for the big reveal. I was lying when I said you would never use so, ka, toa. Because you remember trigonometry class, you understand why we call it cosine error and not sine error or tangent error. It's because this angle, the angle of your error, causes the difference between measuring the adjacent side and the hypotenuse. Now I need everyone to write an apology letter to your high school trig teacher, because you did use it in real life after all. Now here's a real-world example. Both the indicators are set up to measure the table travel on this mill, but the indicator on the right is actually measuring the hypotenuse of a right triangle instead. At this angle, we are a couple percent off of our actual measurements, and there's no way we're making good parts if we set up our indicator like the one on the right. When we straighten the indicator on the right, and we're actually measuring travel and not a hypotenuse, that indicator magically reads the same as the other indicator, and all is well in the world. Now it's easy to see when a dial indicator is set on an angle, but dial test indicators can be more challenging. On this surface plate, I have 2 gauge blocks that are 2/1000ths difference in dimension. So why does this fancy name brand tenths indicator say they're almost 3/1000ths difference? Are the gauge blocks wrong? Is the indicator broken? No, we just have the indicator mounted at too steep an angle. The stylus is meant to be measuring at a flatter angle to the surface plate. But the angle we're actually measuring is more like a hypotenuse of that angle. I hope you guys aren't taking a drink every time I say hypotenuse. I just need to adjust my setup so that the dial test indicator is being used the way that it's calibrated to be used. Your DTI will probably even come with paperwork telling you what the optimal angle of the stylus is. And it actually varies from indicator to indicator. As long as you know what the angle is supposed to be, and keep it within about 10 degrees of that intended angle, you'll be alright. And now again, all is right with the world. The gauge blocks that I know are 2 thou apart actually measure 2 thou apart. All because I'm not doing the microscopic equivalent of measuring the table from corner to corner. I'll remind you that you can always move the angle of the stylus to fit your setup. I've met people who didn't know that, and I guess I can understand why. If no one ever told you, you might be hesitant to just bend part of your expensive DTI to a new angle with your fingers. But that's really how it's done. Lastly, I'll point out that cosine error isn't always a problem. If I saw someone dialing in a 4-jaw chuck with this setup, I'd understand. After all, the goal is to dial your chuck jaws to 0, and 0 with cosine error is still 0 whether you're on the straight leg of the triangle or the hypotenuse. Sometimes angling the indicator is the best way to set up, especially if you're indicating on an internal feature. So there you have it. A little consideration for what and how you're measuring goes a long way in the machine shop. And being aware of cosine error will let you measure and cut accurate dimensions. We've got plenty more videos planned covering machine shop practices and techniques, so make sure you're subscribed to our channel so you don't miss out on that. As always, thanks for watching.